All right. Welcome to Calculus Chapter 1, Lecture Number 4. Today we're going to use your book. So we're in Section 1.2 in the book. And go ahead and turn to page 53. That's where we're going to work some example problems. All right, so we're starting with example 4 on page 53. And the instructions are, in exercise 3 through 10, complete the table and use the result to estimate the limit. If desired, use a graphing utility to graph the function and confirm your result. We're not going to do that, okay? So just going to use the table. Okay, so I went ahead and wrote out this table that's in the book. So we want to estimate the limit as x approaches 2, this is how you say it, limit as x approaches 2, of x minus 2 over x squared minus 4. Now the thing is, if you plug in 2, you will get 2 minus 2, 0 on top, and 2 squared is 4, minus 4 is 0 on bottom. So that's indeterminate form, so we need more work. So one way to do it is to make a table. And if 2 is right here in the middle, x approaches 2, so we're approaching from the left, 1.9, 1.99, 1.999, we're getting closer. And we're approaching from the right, 2.1, 2.01, 2.001, we're getting really close to 2 right here. We can make an estimate of what the y value is. Remember, f of x is just a fancy way, function notation of saying y. What's the y value on the graph of this function as x approaches 2? So we just want to plug 1.9 here in for x. Okay, so that's 1.9 minus 2 over 1.9 squared minus 4. Okay, you plug that in, and you'll get 0.2564. So that's what we'll put here. And we're going to do that for all these values. I'm not going to write them all out, but 1.99 minus 2 over 1.99 squared minus 4. Right? If you put that in your calculator, you get 0.2506. 06. All right, I'm going to do that for all of these. Plug in 1.999, plug in 2.001, etc. All right, you get 0.2501 here. 0.2499. 0.2494. And 0.2439. Well, as you approach, we're estimating what the limit is. From the left, see how it goes 0.2564, 0.2506, 0.2501. What does it look like the y value is approaching? Because right here, when you're 1/1000ths away from 2, you're at 0.2501, 0.2499. Well, it looks like you're approaching 0.25. So the limit, our estimate for the limit as x approaches 2 for this function would be 0.25 using the tabular approach. All right. All right, my music stand is making some noise here. Just have to deal with that. Okay, our next example is going to be number 12. So the next few, we're just going to read the graph from the book. Okay, so we're on page 54. Okay, I hope you can see this pretty well. All right, example 12. It says use the graph to find the limit. Okay, so we're not going to do anything mathematically. We're just going to look at the graph. So as the limit as x approaches 1 of this function, that's just a parabola. All right. So you trace from the left with one hand, trace from the right. What is the y value that this function approaches when x is equal to 1? Well, it's 3, right? The y value is 3. As I come from the right, hit 1, come from the left, hit 1 for x. The y value is approaching 3. So the answer is 3. So that one's simple. There's no undefined area. You just read the graph. All right, let's look at example 14. All right, this one's a little fancier. This is a piecewise function. All right, so it has a value. The algebraic solution to this function is as x approaches 1, the y value is 1. But that is actually not the limit. That's just the algebra solution. The limit is you need to follow the graph. So if you're coming from the right, the limit as x approaches 1, the y value as x approaches 1 is 3. If you're coming from the left, the y value as x approaches 1 is 3. So I'm not really worried about that. My hands do touch at the point 1, 3. So the limit is 3. So this is a case where the algebra solution is not the same as the limit. So hands come together at 3, not 1. All right? So the y value as your hands come together is at y equals 3, not y equals 1, the algebra solution. All right, let's look at example 16. All right, this one is definitely different. Okay, so let's look. We've got the limit as x approaches 3 or 1 over x minus 3. So let's follow the graph and see if our hands touch here. So as we're coming from the left, I've got this vertical asymptote at x equals 3. I'm just going down forever. As I'm coming from the right, do my hands ever touch? No, my right hand is going north. My left hand is going south. That vertical asymptote causes my hands to never touch, okay? So the limit, your hands don't come together. So the limit is does not exist. All right, our next example is example 20. All right, we've got this trig function, sine pi x. What is the limit? What is the y value approaching as x approaches 1? All right, if I come from the left, when x approaches 1, y approaches 0. Right? We're right on the x-axis. As you come from the right, all right, and you get close to 1, the y value is close to 0. So our hands come together and hit together right at 0. So the limit is equal to 0. Okay, now I want to do a couple of example problems. That's a lot of your homework is either doing the tables or reading the graphs. I want to do a couple of examples from the definition of the limit. Okay, so This will help you on at least one of your homework problems. So I'm going to write this out. So this is an example. This is not an example from the book. So given the limit all right, we have the limit as x approaches 2 of 2x plus 2. Find the largest value of delta such that epsilon is less than 0.005. All right, so this is the formal definition of the limit, where we have the absolute value of x, f of x minus L is less than epsilon. We need the form to find delta. Okay, so this is from the definition of the limit. Go back and look at that. X minus c, absolute value of x minus c, and c is just what x approaches, less than delta. So it looks fancy, but you'll see as I work this, it's really not hard. So I'm going to plug my function in here and solve for x, and that will give me delta. Okay? The function is 2x plus 2, so f of x, so you have the absolute value of 2x plus 2. That's f of x, 2x plus 2. What is the limit? Well, the limit is, let's plug in 2. So the limit is going to be 2 times 2 plus 2. We plug 2 into x. So that's going to be 6. So L is 6. And then epsilon is given in the problem, 0.005. So let's clean this up a little bit. I'd have 2x minus 4. Absolute value of that's less than 0.005. Well, I need the form x, not 2x. Okay, so let's divide both sides by 2. That'll give me x, right? So divide by 2, divide by 2. And I would have the absolute value of x minus 2 less than 0.0025. And that answers the question. That is delta, the largest value of delta, such that epsilon is less than 0.005. See, that's how close we can get to the x value of 2. All right, will give us a y value that's in the interval of 6 plus or minus 0.005. Our limit, our y value is 6, so plus or minus that. X would be plus or minus 0.0025. All right, let's do one more of these. Because of the fancy terminology, I want to give you one more example. All right. So let's say find, so given the limit, so you have the limit as x approaches 6 of x over 3 plus 2. Find the largest value of delta. Remember, delta goes with x. Such that epsilon is less than 0.01. Okay, we're going to use the same format. We start with this equation, f of x minus L, absolute value of that, is less than epsilon. What's f of x? It's this right here. X over 3 plus 2. Now what's the limit? We're going to plug 6 in. So minus the limit, plug in 6 to get L. 6 over 3 is 2 plus 2. The limit is 4. All right, that comes just from plugging in 6. Less than 0.01. So that's the absolute value of x over 3 minus 2, right? Because 2 minus 4 minus 2, less than 0.01. So I need the form x minus c less than delta. Well, I've got x over 3, so let's multiply both sides by 3. Then I'll have x instead of x over 3. So if I do that, x over 3 times 3 gives you x, minus 2 times 3 is 6, less than 0.03. All right, and that is your delta. All right, that's delta. Okay, so there's two examples of how to do the epsilon delta definition of a limit, and I think we have one homework problem like that. So here's your homework for section 1.2. And we're starting this on page 53 from your book. All right, I want you to do 3, 11 through 17 odd, 21, 42, 43, 45, and 46. So that's a total of 10. These are, I think, true and false type questions. Study the graph examples to try to answer these. I think that will help you kind of graph out the situation they're describing and then try to answer the question. Just remember, I will work every single one of these problems on a video, so don't panic. I've had students have trouble with these two true and false questions in the past, but it's not that big a deal. I'll show you how to do it, but study the graph examples to try to answer these. Okay, even though it's just a true and false question. All right, that is it for this video, and I will talk to you next lecture.